Hi, welcome to another video. Today we're going to be doing Chapter 2, Section 5, and that's looking at linear differential equations. Okay, so let's get started. So if we look here, we have a format of how a linear differential equation will look like. Okay, this is basically the format. All right, so now I want to put it in standard form on how it's usually going to be seen. You might see it like this, and what you want to do is change it to standard form. Okay? So what you're going to do here is divide by a1x. Okay, well now this one will cancel out, and we're left with y prime. Plus, we have a naught x, a1 of x times y equal to our g of x, a1 of x. Okay, so now this right here will now equal, well, it's essentially our p of x. And this is going to be important. Okay, so now this is now our f of x. And if you look here, this is a order 1 differential equation. So we're going to be looking at linear differential equations of order 1. Okay? And so now to conclude with our standard form, we have y prime plus p of x times y equal to our function f of x. And this is going to be our magical standard form. Standard form. Great. Perfect. Okay, so we're going to move on. And like I said, it's always going to be important to convert it to standard form, because you might see it in the beginning format, and what you want to do is convert it to the standard form to make it easier to do this method. So since us humans like step-by-steps, I'm going to make a step-by-step list on how to find the integrating factor. And so that integrating factor is going to come back up. However, we're going to have to find it. It won't be given to us. So that's a little different this time. So we're going to have steps to find integration factor. If you follow these step-by-steps, you'll be successful in life, and you'll understand the entire universe. I don't know. Okay, so step 1. Step 1, like I said before, standard form. Sometimes the book problems, they'll be tricky, and they won't have it in standard form for you. So you always want to have it in this standard form. Right? Standard form. 2, you'll want to, the integrating factor is found in this way. You have the mu being equal to e to the power of the integral of p x with respect to dx. So that's what's important about finding of having the equation in standard form, because then it makes finding the p of x easy, and it makes it find the p of x correctly, right? Okay, so great, we have our p of x, and if we do that, we'll be able to find our integrating factor. Okay. So step number 3, you want to multiply the mu to both sides of the equations. Okay, great. So for example, if you don't know what I mean by that, you're going to end up with the mu times y prime plus the mu times the p of x, y is equal to the mu times your f of x, right? So you multiply to both sides, now everyone gets the mu. And step number 4, last but not least, is simply integrate. Then divide mu to both sides. So maybe a lot to remember, but once we start getting into examples, we'll figure out what all these steps mean in terms of how you do it, how you implement these to solve a differential equation. Okay, so let's get into solving these differential equations of order 1. How about that? Okay, so this is no longer steps. Now we're doing, problem number 8, which is y prime plus 2x times y is equal to x cubed. And our domain is going to be from negative infinity to positive infinity. Now the interesting idea here is that only linear differential equations have domains. Really interesting. Okay? So, going back to our checklist, we ask ourselves, is this equation in standard form? Yes. If you answered yes, good job, gold star. So our next thing we want to do is find our p of x, which is going to be the 2x. P of x is equal to 2x. Great. Okay, so second thing on our checklist is the integrating factor, right? Is equal to e to the power of the integral of p of x with respect to dx. Great, so now we know our p of x, so that makes it a lot easier. Hopefully we know how to integrate. Let's test our skills. So it's going to be mu is equal to e to the x to the power of 2. Great. So now, 3, we want to have we want to multiply our integrating factor. And now this is our integrating factor. Integrating factor. Right, we just found it. Boom. So now we have to multiply that to both sides of that equation. Okay. So now we have e to the x squared y prime equal to e to the x squared times x cubed. Great. So now we're going to integrate. Well, now this becomes e to the x squared times y equal to the integral of x cubed e to the x squared. I haven't taken the integral of that yet because we'll do it right now. So let's go ahead and do that. Well, what would I do? Well, if I take a look at this on its own, so let's look at it up here. Oh, that's x cubed x squared. So what I could do is I could pull that apart and make it x squared times x. Okay, and I could group these together because why not? And then what I'm going to do is I'm going to integrate by parts. Okay, so now I'm going to use my integration by parts equation, which is u times v minus the integral of v du. Okay, and I'm just going to plug everything in. Great, now I'm going to get 1 over 2 x squared e to the x squared minus 1/2 e to the x squared. And this is plus c. Not, that looks like an e, but it's plus c. So now we have e to the x squared y is equal to 1/2 x squared e to the x squared minus 1/2 e to the x squared plus c. Okay, well, that e to the x power to the square power doesn't look good. And I notice that these two guys have it. So I'm going to go ahead and divide that out. Now, interestingly enough, we don't know what that c is. So we could also divide by e to the x to the power of 2, because it's still a constant. Whatever constant that is, we don't know. So, so now we could cancel these. That's still a constant. I'm going to go ahead and erase this. And now I'm left with y is equal to 1/2 x squared minus 1/2 plus c. And the domain is still your negative infinity to infinity. So that is our answer. Not quite our answer. So if we take a look at another problem, I'll just keep that little checklist up there. Okay, let's look at our next problem. We're going to have dy dx plus y cotangent of x equal to 2 cosine x. Okay, what in the world? I have never seen this in our standard form. Well, it is in the standard form, it's just not in the form that you've seen. That's still y prime plus cotangent x y equals 2 cosine of x. So now that's standard form if you prefer that. Well, now this cotangent, that's simply a cosine of x over sine. So now you have cosine over sine x. Okay. And we also want to state that sine x cannot equal 0. So, great. So that is our p of x, right? P of x. So now we can find our integration factor. So mu is equal to e mu is equal to e to the power of the integration of cosine x over sine x with respect to dx. Okay, so what is that? Well, we could do a u sub. We could set u equal to sine of x, and du is going to be cosine of x dx. Okay, great. So now we have mu is equal to e to the natural log of sine x okay, great. If you don't know what happened there, I can show you. Cosine x dx Well, that is our, that's our du. And our sine of x is our u. So basically what we have is this integration, 1 over u du. That's simply natural log of u. And our u, again, was our sine of x. So we have natural log of sine of x. Okay? Wonderful. Hopefully you got that. Well, now what we're left with is mu is equal to sine of x, because these will reduce each other. Alrighty. So now we're going to multiply that mu to all sides of the equation. So now you have sine x y prime equal to sine x to cosine x. Okay. Now what I'm going to do is our next step was integrating, right? However, I'm going to look at this side right here. This is a good example because it gives us a trig identity. So if we recall the trig identity, 2 cosine x sine x, well, that we can write as sine of 2x. So great. That's way easier to integrate. Sine of 2x equal to sine x y prime. Take the integral of both sides. Great. Now I'm just going to get sine of xy equal to, and the derivative of, the integral of that is going to be, that's 1/2. It's negative 1/2 cosine 2x plus c. Can't forget about that. Okay, so our fourth step was to integrate. And divide. Integrate and divide. So now that we have that, we have sine of x, y equal to negative 1/2 cosine 2x plus c. Okay, well, let's divide sine x to both sides. Perfect. Those are going to cancel out. We get y is equal to okay, then we're going to get negative 1/2 cosine 2x over sine of x. Now I was really hoping that this was sine 2x, so that way we can get a different trig identity or a different trig function. But however, that's not the case. We don't always get what we want. But we really need to state the domain, because that can't be a 0, right? So that's going to be 0 pi. So now this is your answer. And that's how you'd solve it using the integration factor. And that's basically the linear, solving the differential equation using linear method.